Hello, everyone, and welcome back to another episode of Solidity Fridays. Today, I'm joined by Gareth Larkan. He's a developer that does Solidity at Linum Labs. Hey,
Yeah,
Gareth, how you doing?
hello. It's so nice to be back again. I feel like I'm
Yeah, we're
regular.
on quite a roll.
Yeah. Thanks for having me again.
Thanks for joining. Today, we will be covering Sablier, and I think that's how you say it. I'm not too sure. And it's a protocol for real-time finance, so it's a token streaming protocol,
That's cool.
and it's on EVM compatible.
Protocols.
Yes. So that's what they mean by Ethereum smart contracts, because it's not just on Ethereum, I think. Because when I open the dApp and you click on chain, you can choose. There's quite a few. They're on like everything.
Yeah,
So that's
that makes
cool.
sense. That's cool.
Um, cool. We have the docs open in case we need to reference anything. So yeah, it's like it can be used for subscriptions or streams. So maybe for each second I'm using your protocol, you get X amount of DAI, and it just streams continuously while I'm using it. So as a user, you see your crypto earnings increase in real time in the Sablier dashboard. As a Web3 organization, this technology helps you get rid of the hassle of distributing crypto assets on a recurring basis. After a one-time deposit, the Sablier smart contracts will start streaming the tokens towards the recipient without you lifting a finger again. Obviously, you must just be careful to end it then when you need.
Yeah, I'm trying to figure out and like if there's different like if there's different streaming options, like some people get it like every second or every like you know what I mean? Like if there's based on your category, if there's like kind of adjusted to be customizable.
So I
Like,
thought it was customizable, but it seems like it's only every second. But we'll see in the smart contract. Because I
yeah,
thought it would be cool to be like every month send a payment
exactly.
while I'm using like a subscription for like a like that's very like a Web2 subscription fee.
Exactly. Like if it's like a I don't know, like Spotify built on top of like Lens, for example, and then
Yes, absolutely.
pays your subscription every month, for example, which would be cool.
Gareth just came up with a cool app idea if anyone is interested. The other day I looked and there are no nice Spotify vibes on Lens. So
There you go.
definitely give Gareth some equity for when you build that if anyone here gets inspired. Cool. Should we dig into the code?
Yeah.
It's a JavaScript repo, which means it's hard hat probably. Quite cool that Paul Altberg contributed.
Your hero.
One of them. I feel like every episode I'm like, oh, my hero contributed to this one.
Exactly.
Yeah, he did that fixed point math library that I'm quite a fan of. It's like one of my favorites at the moment. Cool. Here's the doc, the README. Oh, shame the CI/CD failed. Okay, should we? It says here, start with our frequently asked questions, get a higher level understanding of how it works, and see our docs if you want to integrate it in your project. Okay, that's cool. So you can use it as a library almost. And then here it tells you where it is. So the core token is in protocol, and dev utils is to share it across all the packages, and this is the smart contracts. Okay, so we'll look at protocol mostly, I think.
Yeah.
And then yeah, usage. Oh, they use truffle. Ooh.
Oh, okay, cool.
That's been a while since I've looked at a truffle thing because
Yeah.
this looked foreign to me. It was like packages, and I was like, where does it say contracts? Cool. And then yeah, this is just cool. So yeah, let's do what they say and go to the frequently asked questions. Basics. Okay, well, these are the ways you can access it. What is real-time finance? A term coined by us to emphasize the wide-ranging use cases for the protocol. We like to think about work as an attempt to rethink the way trust is established in financial contracts.
Okay.
Okay, interesting grammar.
Yeah.
Cool. Yeah, just like you can stream movies on Netflix or music on Spotify, you can also stream tokens by the second. Okay, it's only by the second, I think.
Yeah, I think so.
So imagine Alice wants to spend 3,000 DAI. Ooh, lucky Bob. During the whole month of January. Yeah, she deposits it before Okay, so you make the deposit to Sablier, and then they just stream it from you. It doesn't stream from you constantly. There's one lump sum payment to Sablier, and then they stream it to Bob.
Why? I'm trying to find out, like, well, how would you want to send someone money every second? Like, I just haven't quite figured out a reason for that yet. I mean, like, for example, there's 60 seconds in a minute, and there's 60 minutes in an hour, so that's 3,600 seconds in an hour. So if you have 3,000 die, like, why would you need to send it to someone over the space of 45 minutes? You know what I mean?
Yeah, I know. I'm just trying to think. I mean, the main one I thought of was like, let's say, no, I'm struggling.
Yeah, maybe we'll come across a reason somewhere during
Wait, you know what? Actually, back here, they said, if we open this link, oh no, it's a YouTube. I'm not watching a YouTube thing, but they said that Andreas Antopoulos in 2017 coined the term token streaming.
Yeah.
So he'll in this YouTube video, he'll probably speak about why one would want to, and we will link that YouTube video in the description of this YouTube video.
Yeah, because I'm also quite interested to see, like, I completely get the idea of like streaming, but also it doesn't really work for then like Spotify because
It's not, yeah, it wouldn't be
it's
every
not
second.
monthly. You're kind of putting it
Yeah,
all.
because here I skipped to the bottom earlier and I read ahead when you were asking about why, and it says, no, once stream is created, it is set in stone on the Ethereum blockchain, so you can't change the streaming rate. And then you can cancel streams though. Nice.
But it says once the streaming rate is set, so maybe it isn't only once a second.
Yes, actually, that's correct. Because yeah, I would want it once a day or once a month.
Yeah,
Like,
but
let's
then it's
say
still, like if
I'm
it's
a
once a month, that's fine.
parent
Like,
and I want to give my child an allowance, and I know I want to give them like 3,000 DAI in a year, and then it's
yeah,
monthly.
but then you still have to deposit the $3,000 straight away.
Yes, you do. So what would be really cool is something that just streams from Alice to Bob without having to do a lump sum.
But then, you
And
see, like,
there might be something called Cask Protocol. I think they do that. So maybe we could do a part 2 where we look at Cask.
yeah, I want to because like, so like I've been doing a lot of economics research recently.
Yeah, you have.
Like, my economic brain doesn't work with something like this because like if you're gonna put 3,000, let's say you want to do it every year, right? And you're gonna put 30,000 to distribute to your children over the year, like, would you think that's interest bearing? Because now obviously if you kept your 30,000 in a bank account, for example, and you slowly used money to deposit to your children, that 30,000 is still gaining interest.
No, it's not interest bearing.
Exactly. So like that would be a cool feature that they add on because we are trying to like work away from the centralized technology. So it's something that might be a barrier to entry into a protocol like this for someone because they don't get the interest on that money while it waits. So it'd be cool if they like integrate it into something like Aave or something where they can get yield on it.
Yes, so they get yield and then it streams with the yield.
Exactly.
Or what could be cool is the yield. I deposit my 3,000 and it goes to, let's say Yearn, and then every month it goes, a portion goes to my recipient, and then at the end, all the yield that's been accrued goes back to the sender.
Exactly.
Cool.
So yeah. So I think like there's a lot of economics and stuff that a lot of protocols still need to think about. But this is cool. I hope someone from whoever created this protocol hears this and was like, cool, let's add that in.
Yeah, that would be a cool add-on. Cool. Is audited by QuantStamp. I like QuantStamp, and they do not have any owner or administrator. So they say it's as trustless as an Ethereum smart contract can be, and we'll see that when you go in the code if it is or isn't. Obviously, yes. I guess if there's no way for them to withdraw their funds without the before it gets streamed, and that the sender and the recipient can both cancel the stream, I would trust it. I just want to check accessibility and known issues. A stream transaction must be processed by the blockchain before the start time of the stream. If the transaction is processed after the start time of the stream, the transaction will revert with the following error. Okay. The deposit gotcha. The deposit must be a multiple of the difference between the stop time and the start time, or otherwise the contract reverts with a message. In practice, this means that you may not be able to always use exact amounts like 3,000. You may have to divide the fixed deposit by the time delta and subtract the remainder from the initial number. That's you have to pay the stream a value that is very, very close to the fixed deposit, not quite it. So this is a bit difficult.
Technical.
And obviously they must have used his maths library because it was fixed point math. But this is difficult because I would use this because it's less of a mission than paying my recipient 12 times separately and remembering each month. But if I have to do this whole deposit maths, it might become more of a mission.
Yeah, I agree completely. Unless the algorithm does it automatically, I don't know.
Okay. Yeah, it might help you calculate what you can send. We'll see that. And then you can't send 0 decimal tokens. Oh, you can only do 18 decimals, so you can't do USDC. Oh, wait.
Okay, yeah, because that.
Oh, no, sorry, you can't do USDC. At least 4 decimals. Okay, cool.
Yeah.
I have one more question. Okay, cool. It was just the gas costs. Cool. So it's under packages because this is Truffle. It's a bit of an older protocol, but it's still being updated, which is cool. Let's start on protocol. These are the core. Okay, contracts. Okay, cool.
Do you know a token that has 3 decimals? I was just looking at that. It says do not like.
Do not go below 4. Yeah, I don't.
I do not know one.
No, I only know 8 and 6. Sorry, 6 and 18.
Yeah, so that's something I shall research.
And 0. Cool. So in here we have. I wish in here maybe it was a bit more verbose as to what does what in this README. So. Oh, I just wanted to see something. Sorry. Actually, we'll see it when we go in. I just wanted to see, where do libraries go in Truffle? Anyway, we'll probably see them get. Maybe that's in migrations.
Probably
Contracts.
contract. Trust shared contract. Maybe not. Careful math.
Okay, we got a bit distracted there. Because what's interesting is they use careful math and Open Zeppelin safe math instead of Paul R. Berg. He just the other day released V3. How do you click on the person's profile? He released PRB Math version 3. Oh, this is version 1, I think.
But like that stuff, the Sablier thing we're looking at was like 2-3 years ago. Eh?
Yeah, but look, his last. If I go to contracts, wait, it's not contracts. Sorry, protocol. This was updated 4 months ago.
Yeah.
So it could be a nice little, if someone wants to do a PR.
Yeah.
Contracts. Okay. So now I don't know what's what, if it's migrations or Sablier, but I think it's Sablier we wouldn't want to look at.
Definitely.
My cat just gave a big yawn. I don't know if you heard that.
I did actually hear that. I thought it was something.
So it's Sablier, iSablier, reentrancy guard, and careful math. Interesting about the reentrancy guard. I mean, that's obviously important, but I'm just thinking because the stream isn't something that you can like lock with like a mutex, but maybe it's for something else. I would be intrigued to see what line 9 is, types.sol.
I saw it in the previous folder.
Can we actually look? I'm so
Let's go
curious.
look at it before we, yeah.
Oh, it's just one struct, which is a stream.
Per second.
But I wonder why this isn't just in
Interesting.
the. If it's just one
If it's
struct,
probably
it's probably used in a few places. Okay. Yeah. All right. Next stream ID. I'm finding their NAT spec a bit difficult to read, actually. Okay, so this is uint, which is probably this ID of a stream to the stream struct that we just saw, which has the addresses and the rate per second and all that, all those properties. It's private.
Yeah.
Interesting. Cool. Modifier only sender or recipient.
Cool. So that's
Cool.
basically only, yeah.
It's cool that it just covers both. Because I would have done only sender and then only recipient for other things. But I guess it makes sense to do both. Modifier stream exists. Okay, so the ID needs to point to a valid stream in this mapping, probably. Yeah, streams.
Does that? What? Like they've got a.
Sorry.
They've got a is entity, which must be a Boolean, obviously.
Yeah, let me show you. It is a Boolean.
But they don't need to do that. Like you could just check that the ID exists. Like you don't have to have a Boolean in the actual.
They might set this to false once it's closed, so then you can still keep the ID.
Maybe.
And remember, like, okay, so we've actually had 7,000 streams that are also separate. So you keep the ID incrementing, but this just becomes false for like maybe is entity should be more could be more aptly named is active.
Yeah, I agree.
But yeah, good catch.
Just check that something exists. They could just check the actual
yeah,
ID.
it does just like remove this part almost.
Yeah, or even they could just say that require that
Stream
ID is smaller than next stream ID.
Yes, yeah, all that. Cool. Wow, so contract starts and we start with this is the stream ID. Now, I don't think this would, because we were working with, it gets so interesting with all the decimals. I'm keen to see how they deal with tokens with different decimals. But yeah, this is the smallest constructor I've ever seen.
Tiny.
Cool. So get stream just returns that struct. Yeah, that's all it does. Delta of returns either the delta in seconds, so the change between block timestamp and start time, so how long the stream has been running, or between stop time and start time, whichever is smaller.
So in other words, if the stream stopped, the time of the stream as well.
And then here's where that revert is that we saw in the README in the known issues. It says here if block.timestamp is before start time, it returns 0. So you can only do this once the stream is active. And it throws if the ID is not point to a valid stream. So it's going to do that modifier check is active stream. Cool. So we put in a uint stream ID, and it has this modifier and it returns the delta, which is just stop time minus start time. Or if
if block.times, if it's basically before the start time, it returns 0, and then if the it's before the end time, then
it returns that. And if the otherwise, if this is the smallest, it returns that.
Yeah.
They have a structure. Interesting.
Okay, that's different.
Interesting place for a struct. Balance of local variables. So they had a math error in careful math I saw when we were there. So we could look at that. I think it's a struct with the details of the math error. We could check it out if you wanted. And then a recipient balance, withdrawal amount, and sender balance.
So it's, okay. Once again, I don't think the name of the struct is very solid.
Yeah. And then we're going to probably use it now in this function on 120. So this is called balance of. It returns the available funds for the given stream ID and address. Oh, so it seems like I'm Alice. I transfer the lump sum to Sablier, and then it transfers to Bob, but it builds up in a Sablier like vault, or not vault, but like a pool where Bob can withdraw when he wants and withdraw as much as he wants. It doesn't go straight into Bob's wallet in a stream, I think, because it returns the available funds for the given stream ID and address. Oh no, maybe this is sorry.
This is just how much
This
is
is
left.
just like, let's say I put in 3,000 and I've streamed 2,000. Yeah, you're right. This is 1,000. Okay,
Yeah.
Forget about my little.
Good rant though. I like it.
Thank you. Jazzed up on coffee today, so I'm really digging into this. Cool. We put in the stream ID and the address of the recipient because that's cool. Oh, that's so cool. So I can have multiple recipients.
Yeah.
So I can say I have 3,000 USDC and I want to set it to these 4 people over. The use case I keep coming back to is just a parent trying to pay their kids' allowances.
But just go back to the stream. Sorry, maybe you should open the let stream thing in a different tab. But the stream struct in types because
oh, there's types. Shit. Contracts types. So deposit is your initial deposit.
There's only one recipient. There's not an array. So
you're right. So I'm wrong.
You can't have multiple recipients for one stream. So if you go back to the code,
so it's weird that we have the address who, because let's see who, the address for which the query, the balance.
But a stream will only.
Oh, you know what it could be? Is stream ID address maybe sender, or you can do it from the other side and say you're in stream ID address recipient. How much can I claim? Like how much is left for me? I don't know.
It's public. Stream, yeah. So anyone can call it. So I guess you can call it from both sides. Maybe that's what it is.
Let's see. So they take types.stream, memory stream. Okay, they just get this struct for this stream ID. Then they get the balance of local variables, memory vars. So that's this. So it's math error, recipient balance, withdrawal amount, sender balance. And sorry, I'm so curious. I'm going to go quickly to, it was under shared. I want to go to careful math. And okay, so math error is my bad. It's not a struct, it's an enum. 0 is no error. Then there's division by 0, integer overflow, and integer underflow. Okay. That's interesting. So maybe, because I mean, this is also very 0.5 of them. So maybe custom errors weren't really a vibe until like 0.6 or something. Cool. Then they work out the delta, which we just saw. Then it checks. Okay, so then it goes multiply uint. Okay, so where does it get that? Probably from the careful math.
So it's multiplying delta. Yeah, they. What is it multiplying delta with? Oh, the seconds that are left. I think.
No, the rate per second. So it's working out if this is the check. Yeah.
Okay, this is basically working out the balance now.
And that yeah. And then we make sure there was no error when we did this. Cool. And then they just give a very general statement in the error. Cool. If the stream balance does not equal deposit, it means there have been withdrawals. We have to subtract the total amount withdrawn from the amount of money that has been streamed until now. Cool. So that's what they do here. They go sub uint, but that's weird because it's not. Oh, it is. It is here. There's more. Cool. Okay. Interesting. Yeah.
Okay.
At what pragma did underflow and overflow checks become built into the compiler? I thought it was 0.4, but it almost seems like they're checking here. Oh no, they're not doing a check here. It was 0.4.
Is it not? If B, no, they're not. Never mind.
Okay. For a second, I was like, what if it was like 0.6 and I'm being wrong this whole time? But okay, so that's basically what they do here.
Again, stream recipient, stream sender, you were right. If who equals stream recipient. So then basically if it's the person who's receiving the funds that's calling the function and returns the recipient balance. Whereas if it's the sender, so in other words, the person who put it's Tam giving her children allowance, then they obviously just work out the remaining balance minus the recipient balance and return that. So okay, cool. So if your kids were calling this, it would just return the recipient balance.
Yes. And if I call it, I see how much is left. Have my kids gotten their money?
Yeah. Cool.
And maybe we'll think of more use cases soon. I'll watch that video maybe this weekend. Cool. Struct. Create stream local variables. Math error, duration, and a rate per second. Ooh, we can set a rate per second.
Interesting. So you can set a rate per second.
So by rates, I think they mean like amount per second. So let's say
Like half times a second.
yeah, so instead of saying I want to spend my 3,000 DAI in 12 months, you say I want to spend my 3,000 DAI at a rate of 100 DAI per second. That's my understanding.
But you can't do it slower than a second because obviously you can't put 0.5.
Yes, I doubt you can. Let's check.
So unless they're scaling somewhere, but I doubt it.
Let's see, they might. Create stream. That's the function. Cool. Creates a new stream funded by message.sender and paid towards recipient. Oh, this is the actual stream creation. I'm excited. It throws if the recipient is a zero address, the contractor itself, or the caller. Fair enough. I don't think we need to go through all the throws because we'll see those. So the first is the address recipient, the address towards which the money is streamed. Yeah, makes sense. And the amount of money to be streamed. The token address, cool. Start time. Stop time. Interesting. And it just returns the ID.
I wonder how it knows when the start time is.
I don't know. What I also wonder is here, I would say like I would have token address, and then I would ask people to input the decimals of the token.
Decimals, yeah.
So I wonder where they get the decimals. So he has all the things that will make a throw. So obviously address 0, stream to the contract itself, stream to the caller, deposit is 0. Yeah, start time can't be before the current time. Obviously, you can't retroactively stream something, and same with stop time. Cool. It creates a one of those structs. Well, yeah, and then it does the sub uint where it takes the stop time minus the start time, and that's the duration, and it may or may not return a math error. Okay, yeah, it says subuint can only return math error.integer underflow, but we know stop time is higher than start time because of the requires. Then it says require deposit greater than or equal to vars.duration. So deposit smaller than the time delta. Okay, that makes sense to me. Then they say, so here's where that maths.
Yeah, but they don't do it for you, so you
No, there's no preview or like maybe there is the underneath say like calculate the value I must put in. Otherwise, it gets quite complicated.
On the front end, maybe, yeah, because you need to make sure that if your duration is 1,000, that you don't put in, I don't know, 7,200.
Yeah, I wonder. I wonder if it helps you, like, does it for you. I might play around and try stream. Cool. Okay, now they divide deposit by the duration. That makes sense. And that gives us the rate per second. No. Yeah. Yes, sorry. I thought yeah, okay, cool. That makes sense. For a second, I thought we put in the rate per second as a parameter, but we don't. And then assert that there's no error. Interesting. So they let errors happen, and then they just assert that there wasn't an error. It's interesting. I've never seen that, but I think it's because of the pragma that they were using. Stream ID equals next stream ID. Yep. Now then they make the struct and they initialize it with all the parameters that it needs because we've now derived all of those above. Now we add the next stream ID 1.
That's so interesting. Why they didn't say plus plus?
Right. I was just thinking that. Also, they're like,
Is it
they
over-
take the number 1 and then cast it to uint56.
Yeah,
It's just 1. Why don't you make it a uint8? And also, yeah, why don't you just plus plus?
and just put in an uncheck box just to make sure that it doesn't overflow. Anyway,
Cool. Then they make an IEC20 of the token address.
transfer.
Safe transfer from message.sender. So where do you call approve? Probably with MetaMask on the front end.
Yeah, or on Etherscan or something like that.
Yeah. Okay, emits and events. We haven't seen these events. They must be at the bottom.
Yeah,
And
they
then you return the
be in
stream
the
money.
middle of the contract as well.
What are your thoughts, Gareth? Some people like to have the struct that has to do with that function above the function. Other people like to have all their structs and like data and variables at the top of their contract.
So
Do you have a preference?
yeah, I'm not saying the one's wrong.
No.
But I prefer having all the structs in one place. I really like my.
Me too, unless it's a very, very long contract, maybe.
Yeah.
And then it's nice to have stuff like I've read some stuff by Uniswap where the struct's right above, and it just makes sense because otherwise you would have forgotten what that struct was.
No, for sure. But I also
But if
kind of.
it's a smaller thing,
I like
have it
to
at top.
with larger contracts then rather have my structs in a different in a library.
Like a library, yeah.
In the interface even. Yeah. I've kind of got into liking to put the structs into an interface and then I just work with my interface and my contract next to each other. Yeah. What about yourself?
Then now we can withdraw from stream, and I think this can be done.
Oh, burn. I just asked you, what about you?
Oh, sorry.
Haha.
I got distracted by a Slack message from our streaming host saying how long the episode's been. I also like so I'm a fan of the Diamond standard, and I like how everything's kept in app storage. So I've also started liking to keep my structs and stuff in a separate file, and then just import it into the functions that use it. But if it's a really big, really complex thing, I'm starting to see the point of putting a struct right above the function. But in general, I like having it separate. It also just helps keep the contract a bit smaller. And recently, I've had some contract size issues.
Yeah, same.
Unfortunately, we're actually coming up on time. Awesome. Thanks, everyone. That's been another episode of Solidity Fridays brought to you by Linum Labs. And thanks for joining.
Thanks for having me. Yeah, thanks for having me. That's cool.